Ready and go. So, here you've got two identical semicircles of area 2. This one is occupied by the largest single circle that will fit in it, and this one's occupied by the largest pair of equal circles that will sit inside of that one. And the problem is, what's the difference between the area of this circle and the area of those two taken together? Well, you could start working out the radius, I suppose, of the large circle, but that's going to involve an awkward little fraction with pi in the denominator. One useful thing here would be to answer this type of question straight away, since it's a multiple choice. One useful thing would be if you knew what fraction that took up. There'd be handy things to remember if they were easy to remember, that is. What fraction does the biggest circle in a semicircle take up? And for this one, because what that really says is, by symmetry, and you've got two of these, what's the fraction that the largest circle in a quarter circle takes up? And it'll be the same for the two together. We'll do this one first. So, if you call the radius of this circle r, then obviously the radius of the larger one is going to be 2 lots of r. So what fraction does it take up then? Well, the area of this circle will be pi r squared. The area of this one, since it's a semicircle, will be a half, as I do. Pi times its radius squared. Well, the pi will cancel out the pi, the r squared will cancel out the r squared, so you're just left with a half of 2 squared, which is 2 underneath, so that's easy to remember. The largest circle in a semicircle takes up half of it, which means its area, if the whole thing there is 2, is going to be 1. But that's the part I want to remember. That's quite easy to remember. And what about the case of a circle in a quarter circle? How's that going to work out? Well, again, I'm going to call it r. Obviously, this is a different r now. If its radius is r, then taking this line here, that distance is also r, and since that's a square from symmetry, that must be 1 root 2. That's going to be root 2r. So the radius of the larger circle is going to be r, we'll put it down, r plus root 2 of r. We'll take the r out as a factor. R times 1 plus root 2. So what fraction does a circle take up from a quarter circle? Well, the area of this circle is obviously pi r squared. The area of the larger one is just a quarter circle now, so it's a quarter of pi times this squared, which will be r squared times 1 plus root 2 squared. Well, those parts cancel, the 4 can go to the top, so that's 4 over, and squaring this would be square the first is 1, square the second is 2, so that's 3, plus twice the product, so there's the fraction. I suppose you could sort of remember that, because what does it look like? 4, 3, 2. But there's no fractions like that in the answer, so if you rationalise that denominator, notice that that's a 9 when you square it, and that's an 8 when you square it, so the difference will just be 1. That'll be 4 times 3 minus 2 root 2. When you multiply the top by 3 minus the conjugate 2 root 2, and multiply the bottom by 3 minus 2 root 2 to get, I'll just put it in now that I've been mentioning it all. Because that's the difference of 2 squares, and those squares are 9 and 8, so that's just a 1, so it just comes to that. So that's the fraction it takes up. I suppose it is sort of rememberable, and it is a fraction because 2 root 2 is 2.82. 3 minus that's going to be a lot less than 1. Anyway, if you did know those, it'd be quite easy to answer the question, because what would the areas be? What would the difference in the areas be? Well, if that whole area is 2 and that takes half of it, that's 1. If that whole area is 2, then the area of each half is 1, so it's that times 1, but there's 2 of them, so it's that times 2, so it'll be double that, which is 8 times that. I'll just put it down. So it's 8, because there's 2 of those. So that's what? That's 24 minus 16 root 2 minus 1, which is 23 minus 16 root 2. So there, that was E.